Today we're going to be working on the derivatives of some trig functions. So let's start with problem number 1, which is y equals 2 cosecant x plus 5 cosine x. So to find the derivative of this function, all we need to do is to take the derivative of cosecant x plus 5 times the derivative of cosine x. So notice that the two coefficients or constants of these functions is just set aside right here to so I could be able to find the derivative of each function easier. So y prime is equal to 2 times the derivative of cosecant x is simply negative cosecant x cotangent x plus 5 times the derivative of cosine x, which we know is negative sine x. So you need to know your formula for the derivative of the trig functions so you can easily solve derivatives like this. So now that we have found the derivative, all we have to do is to simplify our answer, and we'll end up with negative 2 cosecant x cotangent x, positive and negative becomes negative 5 sine x. So this is our answer on our first derivative. Now let's have the derivative of the second function, which right now is giving us e to the u and tangent x. So number 2 is y equals e to the x tangent x, and in this function we know that we're going to be using the product rule because we have two separate functions right here. So the product rule we know is just derivative of the first copy second plus the copy of the first and then the derivative of the second. So let's do that in our solution right here. So y prime, I'm going to take the derivative of e to the x multiplied by the second function plus the first function times the derivative of the second function. So we're going to be working on two derivatives, and we know that the derivative of e to the x is simply e to the x, and the derivative of tangent x is equal to secant squared x. So this will become secant squared x. So now that we have found the derivative, all we have to do is to copy the rest of the function, and this is going to be our y prime. So now that we have found the derivative of the second function, we can simply clean this up since our first term and second term has a greatest common factor, which is e to the x. We can separate it into e to the x times tan x plus secant squared x, just to clean it up a little bit. So this is the derivative of problem number 2. Now let's find the derivative of problem number 3, which is, in this case, is going to be a quotient rule. So we have y equals sine x plus 1 all over negative 3 cosine x, and we're going to use the quotient rule, which is low d high minus high d low all over low low, wherein low is the denominator and high is your numerator. So y prime is simply low times the derivative of high, which is sine x plus 1, minus high times d dx of low, negative 3 cosine x all over negative 3 cosine x squared. So now that we have applied our derivative rule, we know that we're just going to be deriving or differentiating these two terms right here. So let's go ahead and copy -3 cosine x and take the derivative of sine x plus 1, and the derivative of sine x and the derivative of 1 is going to be cosine x plus 0. And that will be the derivative of our term right here, minus, we're just going to copy sine x plus 1, and take the derivative of cosine x, which we know is simply negative sine x. So we'll end up with -3 times negative sine x. And that's the two derivative functions using the quotient rule. And this one, we can separate this into square of this and square of this. And we're going to clean it up later on. So let's go ahead and start simplifying our derivative function. So we can copy this together. So we'll have -3 cosine x times cosine x, because it's just 0 right here, subtracted 2 sine x plus 1, and negative is positive, so this will turn into 3 sine x all over 9 times cosine squared x. So this is now our derivative function, and what I can do right now is to distribute this here and multiply this together. So my derivative function will be y prime equals -3 cosine squared x minus the product of this two right here, which is 3 sine squared x plus 3 sine x all over 9 cosine squared x. And I'm going to stop right here because we already have our derivative. We just clean it up a little bit by simplifying our rational function, but this will be an acceptable answer for our derivative for problem number 3. Now let's have the last function. Let's take the derivative of e to the x squared secant x. So let's write it down. We have y equals e times x squared times secant x. So notice that I changed my function again so that you will know that later on we're going to be using the product rule. And we know that the derivative of e to the u is e to the u times du over dx. So we're going to use this as our primary derivative rule for problem number 4. So we'll have y prime is equal to derivative of d dx of e to the x squared secant x, which will be our formula right here. So y prime is the copy of this function times the derivative of the exponent, which is x squared times secant x. And in this function, we'll be using the product rule to differentiate this function. So let's go ahead and ignore this for a little while and just focus on x squared secant x. So we'll start with the derivative of x squared times the copy of secant x added to the copy of the first term multiplied by the derivative of secant x. So in this case, we're going to be working on the derivative of this two function. So we'll have 2x right here. And we know that the derivative of secant x is simply secant x tangent x. So the derivative of that would be tangent x. And let's go ahead and copy the rest of the problem, which is secant x plus x squared. So now that we have found the derivative of this function, we can now write our y prime as e to the x squared secant x multiplied by 2x secant x plus x squared times secant x tangent x. So this is now the derivative of our last problem using the derivative rules for e to the u du dx.